In a previous video, we've learned about the difference between series and parallel circuits. Specifically, we learned that in a series circuit, electrons are forced to travel through all elements in the circuit. And so if you have multiple resistors or multiple light bulbs, the current has to travel through all of them before returning back to the battery. Whereas in a parallel circuit, electrons only travel through one element, one resistor or one light bulb before returning back to the battery. This video will introduce you to some quantities related to each of these two types of circuits. Mainly, we're going to focus on the three quantities commonly studied with circuits: voltage, current, and resistance. For starters, because in a series circuit, electrons are forced to travel through all of the elements in the circuit, that current is going to be constant. Again, remember that current is related to the speed at which the electrons are traveling. So you can't have one electron traveling way faster or way slower than the other electrons in the circuit. That simply wouldn't work. You can think of that with traffic, for example. If all of a sudden one car decides to accelerate and you are in bumper-to-bumper traffic, that just doesn't work. And so similarly, in a series circuit, all of those electrons have to travel at the same speed. Now, in your observations of series and parallel circuits, you noticed that wasn't the case for a parallel circuit. Therefore, the current is not constant. We do have a rule showing the current going through the circuit and being able to calculate how much current is in the circuit. And that rule tells me that the current in the battery is equal to the sum of the current traveling through each element. So if you have two resistors, for example, the current through the battery would be equal to the current through resistor 1 plus the current through resistor 2. If I have 4 light bulbs, then the current through the battery would be the current through light bulb 1 plus the current through light bulb 2 plus the current through light bulb 3 plus the current through light bulb 4. Voltage is another quantity, and in a series circuit, the voltage of the battery is equal to the sum of the voltage through each element. This comes from the idea that whatever energy is given to the electrons by the battery must be converted to some other form of energy before those electrons return back to the battery. And so we've used light bulbs as an example of converting the electrical energy given by a battery to the thermal energy of a light bulb. And each light bulb in my circuit would convert a bit of that energy. Now, if we think about a parallel circuit, an electron would only travel through one light bulb before going back to the battery. Therefore, the voltage of the battery is equal to the voltage through each element in the circuit. So if I have 2 light bulbs in my circuit, the voltage of the battery is equal to the voltage of light bulb 1, and it's also equal to the voltage of light bulb 2. The last quantity I wanted to study with series and parallel circuits is something called equivalent resistance. Equivalent resistance you could think of as being like the total resistance, or the idea of if I wanted to replace the items in my circuit, the loads in my circuit, with a single quantity, this would need to be its resistance. In series, you can determine the equivalent resistance by simply adding together the individual resistances. So if I have 3 resistors all in series, I can find the equivalent resistance by doing R1 plus R2 plus R3. In parallel, it's a little more complicated. For a parallel circuit, to find the equivalent resistance, we actually use an equation that is 1 over our parallel resistance, and that's equal to 1 over R1 plus 1 over R2 plus 1 over R3 if I have 3 resistors, and so on and so forth. We'll of course practice in using these equations and applying them to new scenarios.